Now that we've learned about redox reactions, we can use that information to help us balance some redox equations. And we're going to learn what has to be conserved in redox equations so that we can use that information to help us balance the equation. Uh, we're going to work at this by doing them in halves. We're going to use a reduction reaction and then an oxidation reduction, and then we'll put oxidation reaction, and then we'll put them back together. So oxidation reduction reactions are balanced separately, and then we add them together. The half reaction method for balancing redox equation consists of 7 steps. Now it sounds like a lot of steps, but if you as you do this, it kind of just seems more logical as you're working through it. You're going to be working 2 halves, so each in essence is only going to have a couple steps, and then you put them together. So what we do to start this out is we write the formula if it hasn't been given in the problem, and then we'll take that formula and then we'll write it as an ionic equation. So let's take this formula equation right here, that it's not balanced, it just has formulas in it. We have hydrogen sulfide at the beginning, it's a molecule, and then we have nitric acid, HNO3 is nitric acid, and that reaction will produce sulfuric acid on the right side, H2SO4. It'll also produce nitrogen dioxide and water. So this is the formula equation that we've been given. So the next thing that we need to do is write the ionic equation, which we've had practice in previous chapters of taking these formulas and breaking them apart if they are ionic and not molecular. So here would be the ionic equation for this one. Okay, it's fairly long. You have to take each piece. Now, the reason why we don't break up H2S is because it's a molecule. But then nitric acid, acids are made up of ions, and so we have HNO3 is made up of a hydrogen ion and a nitrate ion. And then on the right side of the arrow, we have sulfuric acid, H2SO4, and that breaks up into 2 hydrogen ions and 1 sulfate ion. And then nitrogen dioxide is a molecule again, so we don't break it up, and water is also a molecule. We don't break that one up either. So the next step is to assign oxidation numbers, and then we'll delete the substances containing only elements that don't change oxidation state. So here would be all the oxidation numbers. So we go through everything that we had in our ionic equation and write the oxidation number for each atom. That's one thing I need to emphasize. It's each atom, not the total, but each atom. So in H2S, we have each hydrogen's +1 like it almost always is. And then sulfide is a -2, which is from our ion chart. H plus, hydrogen ion, is a +1 oxidation state. In nitrate, which is NO3, and it has a negative charge. If we remember from our ion sheet, nitrates are -1. And to make that come out to a -1, each oxygen is -2, and there are 3 of them, so that's -6. So what do I add to a -6 so that the total would come out to that -1? Well, I have to add a 5. So nitrogen is going to have a +5 oxidation number in this equation, or in this formula for the polyatomic ion nitrate. Okay, same thing with hydrogens, +1. Now here is sulfate, and all these oxidation numbers have to add up to a -2. So there are 4 oxygens, and we know oxygen is almost always -2. So 4 times -2 is -8. What do I add to -8 to get -2? I need a plus 6. So this is going to be a plus 6 right here. And then we do something similar over here to nitrogen dioxide. Each oxygen is a minus 2 again. There are 2 of them, so that's minus 4. But since this is a molecule, this needs to add up to 0. So minus 2 plus 4, so nitrogen is going to be a plus 4 here, so that this will add up to 0. And then water, hydrogen's plus 1, oxygen's minus 2. So as we look through here, we can see that sulfur has changed from a minus 2 to a plus 6, and nitrogen has changed from a plus 5 to a plus 4. So those are the things that have changed. And as we set up here, we're going to delete the substances that contain only elements that do not change. So we're going to take out the things that don't change. We can take out the hydrogens because they're not changing, and water and oxygen. Oxygen's not changing. We could take out the water. So those are things that we would end up taking out. So what we have left on the left side is H2S and the nitrate ion. On the right side, I have the sulfate ion and a molecule of nitrogen dioxide. So we've eliminated like all the rest of it, so that we can just focus on the part that's important in being able to balance this. The rest is, we'll add those back later, but for right now, they'd be in our way. They'd clutter it up and make it more difficult to see what's actually going on. Okay, so sulfur, we said, is going from a minus 2 over here on hydrogen sulfide, and it's going to a plus 6 on sulfate. And then nitrogen is going from a plus 5 over here to a plus 4 over here. And then we've just deleted everything else. So the next thing, so we've covered already 2 steps. The next thing we're going to do is we're going to write the half reaction for oxidation. Now remember, oxidation is going to be the one where the oxidation state goes towards more positive, or it goes in a positive direction. And so sulfur is going from minus 2 to plus 6. That's on your number line is going to the right. Okay, so that's we've taken that much out of our previous simplified equation that we just had, and we're focusing now on just oxidation. Now, to balance this, you can see that we don't have the same number of hydrogens on both sides or the same number of oxygens on both sides. So we need to have a method for balancing this. And to balance the oxygens, first of all, in this half reaction, we're going to add 4 water molecules to the left side, because notice on the right side we have O4, so we need to add 4 oxygens to the left side, and the way we do that is by adding water. Now, when do you add water? Well, in acidic solutions, and remember we had nitric acid and sulfuric acid, both are acid solutions. So the method for balancing those is to add water to the opposite side that we need, or to the side where we need some oxygens. And then since we're adding water, which has hydrogen, we'll have to add some hydrogens to the opposite side to keep that part balanced. So what we will have will look something like this. We needed 4 oxygens, well, 4 water molecules down here. These 4 water molecules have 4 oxygens in them. But in the process, we have added 8 hydrogens to the 2 we already have. So on the left side, I have 10 hydrogens. To balance that, I Okay, so to review a little bit, we added 10 extra hydrogen atoms on the left side, but when we brought 4 water molecules to the left side. And then because we have um, a total of 8 hydrogens that we added, plus the 2 that already were there, we needed to add 10 extra hydrogens to the right side. So we added 10 hydrogen ions to the right side. Now, had this been a basic solution, instead of using water and hydrogen ions, the method for this would be hydroxide ions and water. So for acids, we add water and hydrogen ions. For bases, we use hydroxide ions and water. So we have a slightly different method for balancing these equations, whether it's an acid or a base. Okay, so the next step that we need to do after we've gotten to this point, we've balanced it by atoms, but the one thing that's not balanced is charge. The total charge on the left side is not the same as the total charge on the right side. And what we do to balance the charges, we're going to add electrons to the side having the greater positive charge. Okay, so we're going to add electrons to the side that has a greater positive charge. So if we look at what we have up here, the left side is 2 molecules. So the total charge on the left side is 0. There's no, charges. But if you look at the right side, we have 2 things that have charges. We have the sulfate ion, which is a -2, and then we have 10 hydrogen ions, which is a +10. So +10 and -2 gives me a +8 on the right side. And according to our instructions, we are supposed to add electrons to the side having the greater positive charge. Well, the left side was 0. The right side is +8. So we're going to have to add 8 electrons to the right side. So that's why we added this 8 electrons right here, because we need to get both sides to be the same charge. In this case, we need both of them to be neutral, both of them to be 0. Now, the left side had no charge, we said, and the right side had a charge of +8, so that's why we added the +8 electrons. Okay, so that takes care of the oxidation half reaction. Now we need to take the part that was reduction, and the part that's reduction was the nitrate ion changing to the nitrogen dioxide. And as we look at this, first thing that we notice is that nitrogen goes from a +5 to a +4. So that's headed in the negative direction. That's reduction. If it heads in the negative direction charge-wise or oxidation state-wise, it goes. That's reduction. So, but we also notice that the oxygens aren't the same. So since this was an acid, to balance the number of oxygens, we have to add water to the side that needs more oxygens. So it looks like we need another oxygen on the right side. So on the right side, we're going to add a water molecule. We only need 1 oxygen, so we're going to only add 1 water to that. So water has to be added to the product side to balance the number of oxygens. And then we're going to have to add 2 hydrogen ions to the left side because the water adds 2 hydrogens, H2O. And so we're going to have to put 2 hydrogen ions on the left side to balance out the hydrogens. Okay, so as you can see, we have added the water over here on the right side so that we now have 3 oxygens, and there's 3 oxygens here. But because I added H2O, that has 2 hydrogens, I have to add 2 hydrogen ions to this side to get the hydrogens to come out. Okay, so now we have the number of atoms of each element the same on both sides of the equation. So this is what we have so far. The next step again is to balance the charge. So if we look at what we have right here, we have nitrate that has a -1 charge right here. There's my -1. And then we have two hydrogens each at a +1. So that's a +2 right here. That's a +2. If you take this 2 and the positive, we have +2 and a minus. You add those together and you end up with +1. Okay, now on this side, this is a molecule. There's no charge on that, and this is a molecule as well with no charge. So this side, total charge on this side is 0. And we're going to add electrons to the side that has more positive. This is a +1, so we have to add an electron to that side. So an electron is going to be our E negative. I'm not mentioned that so far, but the E negative, it means electron. And we just needed to add 1. So if you look up now at the total charge, here's -1, +2, -1. So that will add up to 0, just like this side does on the right. Now that we've gotten this information, now we're ready to use what we have to start figuring out what kind of coefficients I need to balance my equation using this half reaction method. So we're going to write the ratio of the number of electrons lost to the number of electrons gained. And to conserve charge, we're going to adjust the coefficients in front of the electrons so that the number of electrons lost in oxidation will equal the number of electrons gained in reduction. So the number of electrons that were lost, if you go back to our oxidation, we had to add 8 electrons to the right side, and then we only had to add 1 electron to the left side for reduction. So it was an 8-to-1 ratio. Now, this ratio, whatever we have right here, needs to be in its lowest form. If this ratio were not in its lowest terms, you would need to reduce it. Let's say you had like 8/6, then we could reduce that to 4/3. And the reason why, it'll save us from having to look back at our balanced equation and decide, oh, all those coefficients could be divided by 2 or 3 or something like that. So that'll save us from having to do that step if we do it now. So we're going to multiply the oxidation half reaction by 1. So we're going to multiply it by the opposite. So whatever was, how many electrons I had to add to the oxidation side, I'm going to add multiply by that number to the reduction side, and then the reverse of that. So for the oxidation half reaction, we're going to multiply by 1, so essentially that's going to be the same thing. And then we're going to multiply the reduction one by 8. Okay, so just to kind of track this, because we added 8 electrons up here, we had to multiply the other equation by 8. Because we added 1 electron right here, we multiply this one by 1. So now that we have that, we're going to distribute, and then we'll add these equations together, and we're going to cancel out anything that's common on both sides of the equation. Okay, so we have this from multiplying by 1. We have this one from multiplying by 8. So notice this is 8 times, this was originally a 2, so that became a 16. This was originally a 1, now that became an 8. This was a 1, now it becomes an 8. This was a 1, now it becomes an 8. So now if you look at these, we're going to add them together, and we're going to get rid of the things that are the same on both sides. Okay, so one thing we know right off is we can 8 electrons on the left balances out 8 electrons on the right. And then uh, we just add everything down. The only thing that I may need to point out to you is we had 16 hydrogens on this side, and we had 10 hydrogens on this side. So if I subtract 10 from both sides, I'd be left over with positive 6 hydrogens right here. So that's where that came from. The rest of it is just copying it down. This goes down to here. This one happens to be here. This one is here. Now, notice that the water is only 4, but up here it's 8. Why? Well, because up here we had 4 hydrogens. Here are waters, I'm sorry. And here we had 8 waters. So I'm going to move that, subtract 4 from both sides, and I'm going to get 4 waters right here. Okay, so that's we've kind of stripped down and got rid of the things that were the same on both sides. So each side kind of has its unique thing. So that's what we have right there. Okay, now we're ready to start putting our equation back together again. So we can combine the ions to form the compounds that form the original formula, and then we're going to check to make sure that all the ions are balanced. Okay. Now, there are only 6 hydrogen ions to pair with the 8 nitrates. Okay, remember when we broke apart into ions, we had HNO3, we had hydrogen and this. Well, notice that we have 8 nitrogens, but we're short 2 hydrogens over here. So that's where it says here we're going to have to add some hydrogens. We're going to have to add 2 hydrogen ions to the left side, but what you do to one side, you have to do to the other. Okay, so we add 2 hydrogens to the left side so that they can combine with the nitrates to form this. And then we have our H2S. Then we have 8 NO2, that's good. We have 4 waters that we haven't shown here yet, but we have added 2 hydrogen ions to this side, and these 2 will combine to form the sulfate. Okay. So they will combine to form the hydrogen sulfate over here. 2 hydrogen ions plus a sulfate makes H2SO4, and then we're bringing the water down here to that spot right there. And that was the balanced equation. Sorry, kind of went on too fast. Now, what are some tips for balancing half reactions? This is going to be kind of a summary. Okay, to balance the oxygens in a half reaction, if it's an acid, we add hydrogen ions and water. And the water must be added to the side that needs more oxygens. And then the hydrogen ions are added to the opposite side to balance out the hydrogens. If you're going to balance it, the oxygens for a reaction that's basic, instead we're going to add hydroxide ions and water to balance this out. But here is a very important thing to remember about this step. You can put an asterisk by this. You're going to add twice the number of hydrogen ions that you need oxygens. So if you need 1 oxygen, you're going to add 2 hydroxide ions to that side that needs oxygens. If you need 2 oxygens, you're going to add 4. If you need 3 oxygens, you're going to add 6. So we're going to always do twice as many hydroxide ions as you need oxygen atoms. And then you'll just, obviously, after you've done that, you're going to have to add the number of water molecules to the other side to keep the hydrogens atoms the same. And this is just this slide and the next slide are just reviews of what we just did. So that takes us to the end of this section where we've learned how to balance redox equations using half reactions.